Hello and welcome to the presentation on paper on vulnerability and security log analysis, a systematic literature review on recent trends. My name is Jan Slatina and we wrote this paper together with my colleagues as shown on this slide. In this paper, in this presentation, I would like to talk about following topics. I would like to talk about log analysis in general, what they are. I would like to talk about to detect security issues from logs. I would like to talk how we did our mapping study, what kind of research questions we asked. I will analyze results from this mapping study and I will give you overview of our answers to research questions, and I will conclude this presentation. So, log analysis in general. A log is a record about an event in the system. The system outputs a statement that includes usually a timestamp and some other information that captures some event in the system, and usually multiple of these events creates a state of the system at the particular moment. When we want to analyze these logs, we usually analyze them in files, but it can be, for instance, other storage, as for instance a database, and we want to derive some knowledge from them about defects, runtime errors, unexpected outputs, or intrusion detection. And to analyze such particular thing, there are a couple of problems. The first is volume, because usually a system outputs a huge amount of log statements, and thus just the sheer amount of work poses a serious trouble. Another thing is that we have defects that can be spread over multiple systems, but it can be one defect that just propagates from one system to the other and then match what was the original event of this problem can be very difficult because we can trace the event back to different systems. And when we actually find some defect, it is very hard to analyze it because usually there is a manual approach, but it takes up administrative resources, so we can automate this process, and this is what we studied. We looked on the automatic approaches currently available for security and vulnerability log analysis. So the security and vulnerability, it is really a huge and broad topic. They are industry dependent, what kind of security and vulnerability issues we have. For instance, in Internet of Things, we have usually network issues tied to IP and other issues, whitelisting and blacklisting certain access. With enterprise systems, we usually have issue of authorization and authentication, which users have access to which part of the system. And we have also control systems that control some machinery and physical objects, and there is usually a problem of intruders that try to gain access of the system or of its part. So each part of industry has a different view on what kind of security issues and vulnerabilities they want to detect, but altogether they want to detect these problems in order to avoid monetary losses. What is though common for all of them is time that is divulged to detecting a timestamp, and another is volume, because we need to handle a huge amount of data. Then we also have a previously unknown threats that are usually a problem, and that are also a huge topic of some of the papers that we researched. In this systematic mapping study, we went as follows. We defined our research direction first, that we want to focus on security and vulnerability. Then we created research questions. From there, we went to define the keywords and query. We established sources from which we will derive all the related works. And then we identify existing works by filtering the initial query. We manually assessed filtered works, we categorized it, and then answered the research questions from them. So our mapping study was focused on these sources: ACM, IEEE, SpringerLink, and Science Direct. We took the search query from our from the motion of our paper, which is vulnerability and security log analysis, and we created following statement. We use log mining or log analysis, as these terms are interchangeable. And then we used AND operator, and then we used following keywords: insider threats, because we were interested in threats that goes from inside within the system, not only external threats. So we want to especially identify this problem: insider attack, or compromise a system, that is usually for the control system components. Access or access control or access policy, again more for enterprise system. Or security information and event management, that's again tied to enterprise technologies. Intrusion or intrusions, anomaly or anomalies, or privacy or privacies. So these were the keywords that we used, and on the left side, in the blue color, we can see that we have all the issues tied to vulnerability and security, and in the red we have the log analysis. So our search results from the four most popular sources would be 199 for ACM, and we used just 8. Then we have IEEE with 130, we used 11. It was a higher ratio of papers that were used in this study. In SpringerLink, 224, and we used 10. From Science Direct, 821, and used 5. So altogether, more than 1,300 papers revised, and 34 selected for further observation. So moving to our research questions. First research question was about topics and subjects that the log analysis posed, and what is their distribution. And the second question, we asked about the strategies, tools, and techniques that were used for the analysis. And because we have, the general direction and tools and strategies, we wanted also to ask what kind of benchmarks they used. And by benchmark, we mean a system that has been tested by the strategies that researchers used. And the fourth question was about the possible directions for future research, what researchers thought. And fifth question was how much of information can be extracted from logs. So let's talk generally about the mapping study outcomes. Regarding topics, there were in general two distinctive categories. One was anomaly-based detection, and the second one was signature anomaly-based detection. Anomaly-based detection is something that is was fairly dominant, and it was creating, a pool of log statements that usually were present, and then flagging a one that doesn't match any of the previous one. But the problem was is a high false positive ratio. Another is signature-based detection, when we have a set of rules, and when the rule is different, it's been flagged. But new ways of detecting is then very problematic. So next to methods, so there were a couple of methods. For instance, usually machine learning was employed. Then clustering, also using machine learning. So clustering, for instance, creating clusters by some algorithm, and then comparing these clusters. Next was also natural language processing, when one paper decided to extract semantic meaning of these log files. The areas were already mentioned. It was really Internet of Things, enterprise software system, control software systems, and then various other software components, when researchers weren't so keen to share with us what actually were their system designed for. So maybe it was more general, but sometimes we felt that it was more of a niche thing. So the problems and limitations that were stated across all the papers: real-time analysis, that was a problem in real-time analyzing what's going on. Usually there needs to be some supervised or unsupervised learning. Multi-source analysis, some systems are only restricted for post-mortem analysis. Speed and accuracy of algorithms are also another topic. How to format all the logs so logs are universally readable, and of course scaling of such a system. So in order to answer these questions, first research question: what topics and subjects have been addressed? So from previous slide, it was log mining and anomaly detection that was the most of the work, and then was the log security in general. So anomaly detection is again tied to log security, but these were the most vital. In second question, we asked about the strategies, tools, and techniques. So there were really machine learning, clustering algorithms, some custom processes that usually was created from a mix of all the mentioned, then process mining, text analysis, and word frequency. So the strategies, tools, and techniques were usually data mining, event correlation, statistical analysis, tree structures, and there was even one paper that used outlier detection from bioinformatics tools, and they created a method for recording data into a certain biological alphabet, and from there they were able to see the outliers, which are basically the anomalies that happened, which was a very interesting approach. The benchmarks that were used were usually web-based systems, some cloud-based systems, or IoT, but we also many times it was unspecified what was actually the system about. The next direction for future research is converting really all the approaches from post-occurrence to real-time analysis, improving overall efficiency and accuracy, and finding alternate sources for already existing methods of finding anomalies and other securities security problems from log files, so finding another areas. So in order to answer the next question, how much information can be extracted from logs? So there is security anomaly, and it was, for instance, system deviation, mitigation strategies, malicious behavior, system performance, and system health. So for each industry, something else is important, and these are the pool of information that can be extracted. So to conclude my presentation, I would like to stipulate that we studied the existing work on security in log analysis. We identified topics, benchmark, strategies, future research, and existing works for our in our paper. And for our future work, we would like to diverge into detecting similar log items across multiple files, because we reckon that this was one of the mentioned significant problem and future direction that we should go ahead. So thank you very much for listening to me, and I am very keen to answer your questions. So thank you very much indeed.